So I went back and forth on the title a lot, but eventually landed on this just because it's a series of ideas on how we can kind of fix various friction points, at least as I see it. And really the goal is just to start a conversation. So I have some ideas on things that I think could be improved, but I think the best solution is going to come when all of us put our heads together and try to think through the problems and work towards a solution. So today is just kind of a starting point in that direction. So there's two kind of big goals that I always have in mind when I'm thinking about this and kind of what's drawn me to the project. And one of that is to try to work towards a place where data sets can be treated essentially like Lego blocks. They're kind of self-contained, well-defined enough, and you can take one out and plug another one in with minimal to no effort. Unlike how things typically are today, where each new data set requires some kind of custom curation and kind of cleaning to, and then mapping to different metadata terms or normalizing across data sets. It's just a tremendous amount of work that goes in every time you want to work with a new data set. And obviously, one of the great things about this community and frictionless and the frameworks and specs is that they go a long ways towards solving this problem. But this is, one of the big motivations. Another one that I think about a lot is kind of transparency in how the data is being processed and communicated. This is important in the context of reproducible research and trying to kind of accurately document what's been done to data, the assumptions that go into it, and all these kinds of things. But I think even if you are working with data that's not research data per se, this might still be relevant. So even things like census data, there's some kind of decisions that were likely made along the way to decide, what questions were asked, how they're included, how they're conveyed, where there's uncertainty and all these kinds of things. So the more we can work towards this kind of more realistic picture of data, I think the better. So slightly more detailed version of the motivation for what I'm going to talk about and where I'd like to get to. So to support the creation of data-aware tools. So right now, again, like if I want to write some code to interact with even frictionless data sets, there's going to be some effort involved if I want to work with more than one type of data. And I think there's some things we could do to reduce that friction. To improve support for alternate data types, this is going to be a big focus of today, is how we can, what are the kind of current constraints and limitations baked into how the project is oriented, and how can we start to address that if that's in the goals of the community. To improve support for describing the relationships between data sets. So this is just going beyond looking at individual data sets and thinking about how we can more precisely describe the relationships between them. To create an environment that encourages and supports collaborative and open data curation. So this is just an intuition that's been growing in me for years, which is that there's going to be more and more value in moving towards data curation and kind of creating software and tools and kind of a community that supports that. Because there's lots of data and we're making new data sets all the time. But the quality is not always great. And where a lot of the value comes in my mind is when people take the time to actually take these kind of crude data sets and describe them in more useful ways and package them and make it easy to work with. And then again, laziness, because I want to write code and that I can use generally and not have to rewrite it every time I want to work with a different data set. So some of the key ideas I'm going to talk about today. The first one is to separate the description of structure and domain of data. So by structure, I mean things like the data format or type. So the focus of Frictionless so far is primarily on tabular or table data. So what one might call a data frame in Python or R or Julia. But there's also this domain aspect where you can have a table and there might be different fields you would tend to include if it's a table in the biological sciences versus the earth sciences or some other field or econ. And so we can think about separating those and perhaps describing them separately. Something else I was going to say here. Structured domain. I'll come back to it later. So the second point I was excited to talk about was how we could maybe describe the relationship between data sets. And this is something I've actually been thinking about a lot over the past year or so, and starting to sketch out kind of code in our architecture for how we might approach it. And then just in the process, like in the weeks leading up to this talk, I did a lot more research and realized that this problem's actually been solved far better than I ever could, decades ago. So, and I just wasn't aware, didn't really appreciate it. So I kind of pivoted. I'm going to talk about that aspect of it. It's not that all the time I spent was wasted, and I think there's still values, but rather than me trying to reinvent the wheel, I think we can potentially just use what other clever people have already figured out. And then the last part is this idea of thinking about what the broader ecosystem might look like and how we can move towards this data curation model and kind of support it. So on the left, this is like a hypothetical command line tool that can find data, download data, and then query and do things with it with very little effort. And then a recipe is how one might kind of describe some elements of how the data was generated and curated in such a form that could be put on a GitHub repository, and then someone could fork it and kind of make it their own and push suggestions back. Okay, and with that, we'll get started. So the first one is an abstract data model and how we might improve the support for non-tabular data types. So the big thing I think that is important here that we could do, or is at least worth considering, is to make formal the types of data that we want to support. So to sit down and think about what are all the data formats that we as a community and that the Frictionless project as a whole would like to be able to interact with. So there's one that's already well established, which is tabular data. The one that I work with even more often in biological science is matrix data, where the values in the table, so to speak, are uniform. So they're all measuring the same thing. And then you might have, your genes would be your variables on one axis and then patients on another axis. So it's similar. It looks at first glance kind of like a table or data frame, but it's fundamentally kind of different in what it represents and what it means and how you can interact with it. And also there's value in having tables to actually annotate the rows and columns in many of these biological matrix data sets. Whereas with tabular data, if you had annotations for the rows, you might just include them as new columns in the table because you already have this heterogeneous table. Although I would also argue that there's cases where it's still separate, even with table data, to have a separate kind of row and column annotation matrix table, but I'll talk about that later too. So image data is another type that people work with very often. And then you could go on. So there's audio data, spectral data. The important thing is we should just think about what we want to actually support and what is currently missing from the framework. And for each of these that we do want to support, whatever code bases that we're working on, we should start to try to incorporate tests to see if we can actually read these formats and write these formats. And I don't think, even though it will take some work, it shouldn't be too bad, especially just like the very basics. And yeah, the first step is just to decide what we want to do. So the reason for talking about this now, though, is I think the sooner that we start to clarify what our intended scope is in the long run, the better we can start to align the architecture to actually support this. Whereas if we get too far with just kind of assuming or implicitly assuming that kind of all data is tabular data, you end up with an architecture that works really well for that, and then suddenly becomes really awkward when you want to try to add these other things in. So then there's the question of whether or how we might separate data structure and domain. So one thing that's really great is Frictionless is modular by design. So this is taken from the Frictionless docs, and it talks about how you can kind of compose these different specs together to create the tabular data package spec. And this is fantastic, and I think exactly the direction that we should go in. Where it's kind of lacking, or where little work has been done so far, is kind of the domain specific extensions. So there's this kind of example fiscal data set that I'm not sure if anyone's using. And it seems to be there maybe primarily just to showcase how one might actually go about doing this kind of domain specific extension. And I do know that people within the community have done this some for their specific problems, but at the kind of higher level of the frictionless specs, there hasn't been a lot of work done to try to formalize this. And I think it's one of the goals of the project to not maybe to leave it open and allow the community to build their own kind of extensions. However, I think at least early on, there's some value in us taking some intentional action to guide or to decide these high level things. And so the reason why, well, I think I'll talk about, yeah, when we get, I'll talk about now. So the things to consider when we're talking about structure, separating the data structure and domain. So one of the big reasons why I think this is useful is that even different domains often talk about the same kinds of things, or there is some overlap. So in many fields, it's useful to record and talk about time, or there might be a spatial aspect of it. There's data processing is another common thing for many fields. So there's different levels of processing, data processing. So rather than, if you kind of let every field come up with their own extension to the spec, what's going to happen is they're all going to come up with their own decisions on how to talk about these things. And then when someone wants to come along and build a single system to interact with all these data sets, they now have a whole bunch of different things they have to figure out too, and essentially like more friction to deal with in the system and the code. Whereas if we kind of get everyone to sit down in the table together and say, okay, well, how do we want to talk about time, and how do we want to talk about space, and what do we want to call processing, and so on, we're not ever going to agree 100% on this. I think some fields, have their own needs or just their ways of doing things, but we can at least find some middle ground, I think, where we can agree on some things that we can talk about in common. And I think that would be beneficial. So I'd call this like a core data model. And then from there, from this core data model, so we agree on how we want to talk about these common things. And then each domain can kind of extend that to add their own things that are unique to their fields. So another thing that I think is worth thinking about that I don't know the answer to, which is whether we can adopt something like a mix-in approach. So here, the idea is instead of just having one spec that's like a tabular data package, you might have, or like, yeah, bio, well, here, I'll do it the other way around. So one could have the data structure or data type, and that would be tabular. And then the domain would be biology. And so the spec would kind of be these two things combined together, versus a different approach, which would be to have a tabular biology spec, where they're it's a single spec that describes both. And it might seem like this is the same thing at first glance, but when you start to think about the kind of code architecture, and in particular, like if you're thinking about how you might have class diagrams to represent the different objects in your system, these lead to different ways of structuring the code. And I've done this a few times in the past, where I start to try to flesh out this data model in the context of working from something abstract to a more specific bioextension. And I've pretty much always done it this kind of inheritance way, where you have like a bio data set that is a sub or inherits from matrix, which inherits from some abstract data set or data package. The problem with this is that you end up with a lot of redundancy. So if you have bio data matrix, then suddenly you have all these biology specific extensions that you want to build on top of this generic matrix class. But then suppose you have a bio tabular data set, then you end up having a lot of the same things. And so there's a lot of redundancy in the code base at the end. And then if you imagine extending this to multiple fields, then suddenly there's all this redundancy for all these fields. So a different approach that I think we could explore that might help alleviate some of these issues would be to try to separate out the kind of functionality related to the data structure or type, and then the domain specific aspects. So you could essentially say, these are the fields that are relevant to biological data. And then whenever you have a data type, you can just add these fields on top of it. And so the logic in the code can potentially be separated out. again, I think maybe the solution is something in the middle ground, because even within a single domain, you're probably going to have different fields that you want to include depending on the data type. So it might be different for a biomatrix, or different types of biomatrices versus image data and so on. But I think, again, we can think about this now and start to at least work towards it. And yeah, when I think about this, it's useful to think about class hierarchies, and then simultaneously think about kind of like a hierarchical data model, or how we might actually write out the specs to support these, because they kind of go hand in hand. I think a good first step towards this would be to create a working group. I kind of alluded to this, I think, in the last meeting or an email. But I think if we just get people from all the different fields, and also not just all the different fields, but people working in different capacities. So for instance, you have people who are consuming data and using it to do research and answer questions. You also have people working on the systems to serve data, so data repositories and catalogs and so on. So I think getting people that are coming from these different perspectives and from different fields together to think through these things will end up coming up with a solution that works as well as possible for as many of the different parties, and try to kind of cover all our bases. So this has, and a lot of different fields have kind of thought through this, right, and come up with their own data models and how they want to describe things. And so we can definitely build on top of that as well. So here, I think I'm just remaking the same point I just did, so we can skip over this. But yeah, formalize our expectations and increase compatibility and code reuse across domains. Okay, that's another aspect. So if we can do this, and to the extent that we can agree on these common things, then when someone writes code in the biological sciences for interacting with the data set, the chances that it can be reused in a completely different field are higher. Okay. And then I just point out here, like, this can all seem like a lot at first, especially when our starting point is just to have support for one data set in that, or one data type, tabular data. And I'm now saying we should support image and spectral and audio and X, Y, and Z. We can iterate though. So we're not going to get it right the first time. I think this is just the nature of the beast. Like, these are problems that no one has solved. And especially, I would say, this problem of doing it across all different fields. I think people have done a really good job within different domains, but there's been not as much effort that I've seen to try to solve it in this kind of abstract and very interdisciplinary way. And yeah, the important thing is just to start and try, and then we can kind of see how things are going and modify the course. So the second thing I was planning to talk about a lot, but I think I can just kind of refer to another effort, is to how we might talk about the relationship between data. So some motivation for why one would even want to do this. You might have projects that involve integrating data from different repositories to answer questions, or create data collections of related data sets. You could also do this in the context of data provenance, where you have like a workflow and you want to show the relationship between different levels of data processing. And then just more generally, to be able to describe the relationship between data. So you could have two data sets that are discussed in the same scientific paper, and that's a relationship that you could potentially describe between them, but you need a kind of syntax to do that. So here's another simple example of how I might use it in my own work, would be this idea of having a gene expression matrix, and then you would have, in reality, this would be flipped because of convention in bioinformatics, but we'll just pretend that bioinformaticians do things the proper way and they put their samples in the rows. And then you might have some kind of metadata that relates to each of the patients or the samples in the rows. And then we have our features or genes on the columns, and then you'd have a whole separate table on describing kind of information about each of the genes. And this could be depicted in this kind of relationship. So yeah, it turns out it's not a new idea. I think many of you have already known of this, or are more kind of hip to it than I am. But linked data has been around for almost a couple decades. And things are described with kind of these permanent IDs, which are often associated with a URL. And then very often linked to ontologies and control vocabulary. So things are described very precisely. Node relationships tend to be expressed in triples. So subject, predicate, object. And yeah, I know I'm rushing through this, but the point is not to talk about or give a linked data talk today, because it's still something I'm reading about and learning about now, and also it would just take us a long time. So I'll just briefly introduce it. So formats, though, the common ones that people probably come across are RDF, and then other ones I found are labeled property graph, or LPG, and JSON LD. LPG, I think, kind of tries to provide some additional ability to annotate the nodes and maybe edges in this. But again, like I'm not too familiar with it just yet. So I think a good example of how we might be able to use this in our own work comes from a separate project, which actually does a lot of similar things to frictionless, which is RO crates, or research object crates. I imagine some of you have come across this, and maybe it's even been discussed, and I just wasn't on my radar. But it's a really interesting project. They're similar to frictionless. They're trying to think about this problem of packaging data in a way that it's kind of both easy to use within code and kind of machine applications, so machine readable, and also that captures information about the provenance and the nature of how the data came to be. So again, like really similar goals. One thing they do differently, though, so just like frictionless, where we have this kind of data package.json or YAML file, they have an RO crate JSON file. And this is just an example taken from their documents. And you can see, so they specify the spec is RO crate. This is the file itself, the RO data crate metadata JSON. And then they say kind of the top level ID is this /. So this, just like data packages, tends to exist in a directory, although it can also be virtual from my understanding. So these IDs can point to remote objects as well. And then here's this ID that's referred to at the kind of top level. And you can see it's a data set, and they have some information about the data set. So I think for anyone who's worked with frictionless for a long enough time, this starts to feel a little bit familiar. So it stands for research object crates, similar to frictionless data, but it's aimed specifically at research data. I think their focus, as far as I can tell, is biomedical data, but I imagine they're not just thinking about that. And instead of JSON, it uses a modified version of JSON LD, which stands for JSON linked data. So it's alternative to RDF for describing this kind of linked data and relationships between data. There's a RO crate metadata file. There's also, interestingly, they kind of mention the ability to include a HTML file within the packages. And I thought this is kind of a neat idea. So we've often talked about how we can create these little web deployed versions of a data package. And even though I haven't looked at this closely enough to know what the limitations are, and I know in some cases like static HTML pages can only do so much, but still the idea of having something more than just a text description that is packaged with the data doesn't seem like a terrible idea. So I think the best way to get a sense for what this is like is just to show you. So there is an RO hub. So it's a site that you can use to find these kind of research object things. And this is literally just like the first one, or one of the first ones that came up when I searched for, or like kind of listed the most recent RO crate objects. And so this is describing a single such crate. And yeah, you can see it has this nice little dataset landing page. Here's the contents of the crate. So this would be like the file structure in a frictionless data package. They included a Jupyter notebook, and so on. You can find kind of details, and there's other things you can do with this. I'll get rid of this. So what does this actually look like? So here's the crate. I unpacked it. When I downloaded it, it came in a zip file. This is the metadata JSON file that I was telling you about. So exactly this kind of thing where you have the spec for RO crate, point to what the kind of top level or main data set is, and then some information about that data set. And then, yeah, there's the HTML file we could open up. It's pretty basic in this case. It doesn't look nearly as nice as the landing page I showed you. And then also an IPython notebook, which is kind of neat. So much time. Okay. So definitely worth checking out. And the point is just to show people who aren't aware, because this wasn't something I had really come across or looked into too closely before, that there is this parallel effort going on. Funnily enough, they have monthly open meetings that happen to be on the last Thursday or the fourth Thursday, I think, of each month, and a little bit later today. So again, like a lot of parallel work, not the same, but we could potentially work together and learn from each other. And I think that would be a good direction to go in. And I do think after spending some time researching the linked data and kind of the benefits of it, that it's something we could at least consider seriously, or see if there are ways we can benefit from it, because it does a very elegant job of solving the kind of problem I was talking about before, about how to precisely describe the relationships between data. I haven't used it enough to know how well that would work for the goals of the frictionless project. And I suspect that there is a trade-off in terms of complexity, that in order to support this, I mean, just from my looking at the JSON LD files associated with the project, they aren't always as readable as the frictionless data package files. So maybe there's a bias towards it being more on the machine readable side and less on the human readable side. I think that this is something that they're conscious of also, and trying to kind of prevent. But all this is to say, like, yeah, something to think about and discuss. And long term, it's hard to see us not benefiting from some capacity of this linked data model, just because being able to link to ontologies and control vocabularies in very precise ways, and link to data within like a workflow is incredibly useful. Okay, so data package ecosystem is kind of the last thing I want to talk about. So here is how I would see an ideal ecosystem, or kind of my take. So the first thing you need is some well-defined specs and how we want to talk about data and describe it. And I think we're partway there with the frictionless specs that we have now. Likewise, ideally, you would have libraries in different languages that people use to interact with data, and a consistent API for those libraries. We have some implementations in frictionless in different languages. I haven't worked with them closely enough to say whether the APIs are very consistent, so that you can kind of take code in one and then know roughly what the function names are in the other. But that's something we could also think about and try to work towards in the future if it's not the case. Command line tool, so I think I have some more examples in a moment, but a tool for interacting with finding data, summarizing data, and doing things with the data package, I think would be useful. This is something where, again, we have some of the work's done, and I think there's room for improvement as well. And then the other things that we're maybe missing, or at least I think need more effort, would be like a data repository for serving data packages. And then also data recipes, this idea that I talked about. So yeah, so what a command line interface might look like. So here's now a hypothetical extension of the existing frictionless command line tool. So the first thing that would be useful would be to have a way to interact with local data packages. So being able to, show info for a package with a given ID or a path or your current working directory. So this, a lot of this is already supported. The listing available data sets is not. So this idea is that it would be nice if basically you could have a local remote model where the tool knows about some remote repositories, and it also kind of has a local repository of data that you've downloaded in the past or created. And when you do list, it would be able to kind of list all the data sets that you have locally. And you could do things like sort them by date, or maybe assign them to projects and show all the data sets related to a project. If the data set has some kind of views embedded with it, for instance, either static plot images or Vega Lite JSON kind of views, you could pull those, list those, and then visualize them using this command or API. And then likewise, being able to launch a code environment for in the language of your choice for a data set with minimal effort is useful. Whoops. And this is something, again, I think Evgeny has already been working on incorporating, so we're already moving in the right direction. Another thing that is not currently possible, but is something that I think we could think about doing in the future is this ability to find and download remote data. Actually, I think this is something that even has been discussed somewhat recently in Slack and is on the radar. So things like being able to download a data package from GitHub or Zenodo. But again, if we're able to come up with some way to host data packages on a repository such that you could just kind of provide them or add different repositories that you know to your configuration and then be able to search and pull from those repositories by ID, that would be great. And yeah, search also depends on being able to search remote repositories. So the functions of a data repository, the basic ones that we'd want to be able to support are hosting packages and then allowing searching and browsing the repository. Each data set would have its own landing page. And importantly, I think it'd be good to be consistent in the view presented for a data set for the web UI and command line tool. So here the idea is that each data package should be self-contained. And if you have some functionality to kind of summarize the data package on the command line tool, there are probably some key fields that you want to pull and present. I think we should decide on that upstream and then present the same summary and ideally as close a format as possible in both a web UI and a command line interface. So that way, when people are working with one or the other, it feels kind of consistent. And then views will vary by data type. So this is, yeah. So for each domain, there's different data types that one tends to work with. And those different data types are often associated with certain types of visualizations or summarizations that are the most helpful. And so the web pages and the command line tool could essentially be extended so that it would modify what's presented based on the specific data type rather than just always presenting the exact same thing regardless of the data type. And then, yeah, long-term, if we had this model, users could essentially add repositories to have them included in their search results. So two possible approaches. The first is create our own, essentially try to create an open source repository that meets these needs. It has the benefit of giving us full control over the API and would allow us to basically put out this software, and then anyone like a university, whoever organization decides they want to host a bunch of packages, they could set it up and do it. The disadvantage, obviously, is this is a tremendous amount of work. And it's not only that, it's a lot of this has already been probably solved. So we wouldn't necessarily want to recreate this from scratch anyway. Another possibility would be to try to wrap or work with existing repositories. So if we could work with Zenodo and similar repos and convince them or find a way to be able to basically search and download data programmatically without requiring a user to manually kind of set up their own API key and all this stuff, which is going to be too much for a lot of users. That is another approach and perhaps a kind of lower hanging one. And for this, I would give a motivating example is conda. So this, if for those who haven't seen it, conda solves a kind of similar problem to this, but for the software side of things. So what conda has is this decentralized repository model where there's different repos set up that host software that people can download. So the three big ones are Anaconda, CondaForge, and Bioconda. And then using a command line tool, you can search for and install software. So this is aimed at basically facilitating the creation and sharing of reproducible computational environments. So I think, again, I can maybe show with an example would be the easiest thing. So that's just the way you might create an environment. Let me do this. Is you can create like a requirements.txt file, and you can specify what you want to be included. So for instance, there's the frictionless Python library. We can also say that we want, Python greater than 3.10 and so on. And it includes R packages as well. So you could do like our tidyverse. I won't include it here now just to keep it short. And then to create an environment, you do conda create env. And it's going to basically figure out what it needs to install to create this environment. While this is running, I'll try to finish the thoughts here though. So why I mentioned this, because this is not, again, this is about software, not about data, is I think I really like the model that they have for this kind of decentralized repository system, where they allow different institutions to serve the software packages and indeed the recipes, as they're called. So conda recipe is how you describe the software packaging. They live on GitHub, so anyone can kind of go and kind of modify it for their own needs, or submit a pull request if they find a better way to prepare the software. And I think the same kind of model would serve really well for data. It's just that no one's done it yet. Yeah, it's still going. I could talk about this all day. It's true. Here's the key points for the data recipes. So, and some of this I mentioned before in the last time I talked in 2021, but the basic intuition is that data processing is an art. So that for a given raw data set, if you give it to 10 different specialists, so to speak, in whatever field you're in, you're going to get 10 different results. This is not kind of how people think about it still. I would say even in the scientific community, people think that there is maybe a right way to do it or a best way to do it, and that if you just have enough training and expertise, then that's what you need to do it the right way. And I just don't think it's the case. I think there's so much subjectivity and uncertainty baked into the process of how data is processed that is unavoidable. And so the best thing we can do is just to try to be aware of that and document it well. And I think a recipe of bringing a lot of that, what typically happens behind the scenes kind of before publication or before data is shared, all this kind of decision making into the open and kind of embedding it in a GitHub repository in such a way that people can see what went into it and then maybe make their own suggestions would be a better approach. Let's see if kind of finished. Nope, still going. So there's, yeah, as far as I know, there's no good community for this kind of data curation in an open way. And there's not really kind of the tooling ecosystem that supports it. So I think this is an area where Frictionless has the potential to step in and fill this need, because Frictionless is kind of by its definition very broad in scope and thinking about these questions of open data. And this is one of the big ones that's on my mind a lot that I think we could work towards. So what's needed is a software ecosystem to make it easy, because if it's not easy, people aren't going to do it. It's already a lot of work just to get people to try to describe the data in like a publication, but that's not really the most useful version of that. And then also a culture shift. I think a lot of the reason why this isn't the norm today is that people are maybe sensitive about being wrong because there's so much uncertainty. And I think people realize that when they're analyzing the data and processing the data, they are afraid of other people, seeing their decision making and maybe critiquing it. So I think we need to change that and be a little bit more willing to discuss our own uncertainty in things and convey it transparently. And I think it's only through that that we're actually going to get to the kind of the best forms of data processing, so to speak. And then, yeah, recipes is basically a kind of convenient framing or way to think about how we might process this all up or capture this idea. So transparently describing the data processing and then put it on something like GitHub so that people can fork and iterate on it. And this is, again, it's not just the shift towards like people improving on an individual's recipe for processing data, but rather shifting from individuals doing this to a community. Like in biology, for instance, there's some data sets that are used by thousands of people. And in theory, like it could, the way the data is processed right now, well, actually what happens is it ends up being processed by thousands of people in different ways. But really, there's a lot of room for benefiting of people coming together to try to think about what are the most effective ways to process the data, and then kind of iterating on that as a community rather than having some authority upstream provide the data and then people modify it afterwards. So next steps, so these are all a bunch of RMWB ideas on things that we could do or things I think are useful to think about. What can we actually do with this? Possible next steps. I would say the biggest one is just to actually make an intent and start to work on this or think about it. So form something like a working group to work on the specs and the code ecosystem. So I think, as we talked about last time, the specs are now open for us to actually kind of work on, but there's no formal process right now for how one would suggest kind of changes to the core frictionless specs. So maybe that's a good first step, is think about like what would be an appropriate process for coming up with changes and accepting them and voting on them and all that kind of stuff. We can maybe meet once a month. Definitely aim for diverse representation. Again, of people in different fields and working in data in different capacities. It'd all be useful perspectives. There's a bunch of spec issues on GitHub, like people submitting spec ideas and things that just haven't been addressed. And so this is probably also worth trying to work through if we're thinking about this bigger goals of how we can improve the specs. Other specific possible topics to discuss, so based on the things I talked about today, are choosing a common data model and fields and how we want to talk about them. Thinking about adopting JSON LD, like obviously it's a different way of thinking about and describing the data from how frictionless currently approaches it. So we can, because JSON LD is just JSON, we could essentially embed that information within the frictionless spec, and that's one possibility. But perhaps longer term, like 5-10 years, it's worth thinking about whether we would actually want to modify the spec itself to be more of this kind of linked data nature, and that's a bigger change. And then, yeah, issues, we could start to think about the software ecosystem things, like how we want to make it possible to search and download frictionless data packages from the command line from a repository, and what hurdles are in the way of doing that. And then this is another thing I think we could do that is useful, is to reach out to some of these other groups that are working on similar problems. In particular, the one that I mentioned today, the RO crates team, they're actively working on this and solving some different problems and a lot of the same ones that we are. And it seems like, if nothing else, we could at least benefit from sitting down and sharing our own experiences and seeing if there's areas where we have common problems we can try to work on together. And also just ensure that we can kind of coordinate and support each other's efforts. I think it's unlikely that we're going to sit down and say, okay, well, this is the right way, so we're all going to jump ship and do it this way. I think people are kind of invested in their own ideas, and that's okay. And again, like, the needs are not 100% identical, but I think there is room to work together and learn from each other as well. So that's it. Thank you.